I want to prepare a 250 milliliter buffer solution like the previous problem. In other words, I want to prepare the buffer solution at 4.8 using my propanoic acid. Okay. If I use 150 milliliters of a 0.20 molar HPR propanoic acid, what is the molarity of the sodium propanoate solution I must use to achieve the desired 4.80 pH? Okay, so we said we have a propanoic acid solution, and we know that the ratio has to be 0.813. That was our previous example. Now I want to actually prepare the buffer solution. I want to prepare a buffer solution, 250 milliliters of that buffer solution. Well, I use 150 milliliters of a 0.20 propanoic acid. I know that I have to add, another 100 milliliters of the sodium propanoate. But what's the molarity of the sodium propanoate solution that I must use in order to achieve the desired pH? See? Please, it's very, very important that you understand what this question is asking. I want a pH of 4.8. I've already calculated the fact that I have a ratio of 0.813. I'm preparing 250 mils of that buffer solution. I'm using 150 mils of a 0.2 molar HPR. Well, 250 minus 150 leaves me 100 milliliters of solution of sodium propanoate. However, what's the molarity of that sodium propanoate I need in order to get to a pH of 4.80? This is actually just a stoichiometry problem, believe it or not. So let's go ahead and do this. Well, we know that our, actually let me use the actual identities of the species. We know that our ratio of propanoate to HPR is equal to 0.813. Okay. Well, I have 0.150 liters, that's 150 milliliters, times 0.20 moles per liter of the propanoic acid. That means there are 0.03 moles in that 150 mils. 0.030 moles of wait a minute. I'm using HPR. Yes, that's right. Moles of the HPR. Okay. Now this 0.03 mole of HPR is in 250 milliliters. Okay? Because again, I'm adding another 100 liters of solution, so that the Henderson-Hasselbalch equation talks about, I'm talking about the molarity of the whole solution. I know that I've used 0.030 moles because I've used 150 mils of a 0.2 molar, but now it's swimming around in 250 mils. So 0.030 moles divided by 0.250 liters gives me 0.12 molar HPR. Well, I know that my PR minus concentration divided by my HPR concentration, which I just found is 0.12 molar, is equal to 0.813. Therefore, my propanoate concentration has to be 0.813 times 0.12 equals 0.09756. I'm not worried about significant figures here. Molarity. And I also know that I'm going to have 100 milliliters of this because I had 150 mils of the propanoic acid solution. I want a total volume of 250, so I need 100 milliliters. Now I can go and I can take some solid sodium propanoate, I can drop it into solution depending on, I weigh it out in terms of grams because now I know what concentration I need. I hope that this made sense. I needed a buffer solution at a specific pH. I knew that if I can find an acid that has a pKa close to that pH, and I knew that the ratio of the base to the acid is going to be 0.813, and based on the rest of the problem, given the volumes that I had and the molarity that I was dealing with, I was able to calculate the molarity of the sodium propanoate solution that I would need in order to achieve that 4.80 pH. I would definitely recommend going through this problem a couple of times just to make sure you understand what it is that we did. This is sort of a whole bunch of problems tied together. Okay. Well, this pretty much covers our discussion of buffer solutions. Next time that we see each other, we're going to start our discussion of acid-base titrations and titration curves. So thank you for joining us here at Educator.com. We'll see you next time.